Yeah, very warm welcome from my side as well. Yesterday I learned that there are also a lot of English-speaking people here, so I decided to change my journey on Pankl to English here. I hope the German speakers will forgive me for that. I would like to take you on a short journey of Pankl, a bit about motorsport and our history, and the first part of this journey is a short video giving you a first impression of what we are doing.
Balance. It's the vital force that governs our whole planet. The interplay between rapid progress and mindful preservation, relentless speed and enduring stability. This is the challenge of modernity, a continual balancing act. We at Pankl are on the fast track of technology, yet we steer responsibly and with foresight. Quality is our compass, speed our heartbeat, and smart sustainability our destination. Our journey is a testament that sustainability and technological success can harmonize. It's a balance we refine each new day. Today, we gather to honor this balance and look toward the future. Let's continue shaping the world of modern mobility. High tech, high speed, high quality. Smart transformation is technology driven.
High tech, high speed, high quality. These are our logos, these are the core values of our company, and if you've seen some of these pictures, some of them might seem quite obvious. High tech, yes, we deliver to the motorsport industry, we deliver to the aerospace industry, high performance vehicles, but high tech is in our DNA, it's in all of our engineering that we have. High speed is obviously the speed of our customers, but also the speed of our engineering, the speed of our production, the speed of our response. And high quality is not only the microns of our products, it's the trust that we gained with our customers, the trust in us, the trust in our capabilities. We started in 1985. Gerald Pankl founded the company in 1985. The titanium connecting rod for BMW in Formula One being our first product. And this is also where the connection with CADFEM started, because Mr. Müller and Mr. Pankl, they were discussing the first optimization of titanium connecting rods. And since then, we developed ourselves to be a core supplier to the motorsport industry for engine components, piston conrods, crankshafts, suspension components, hubs, uprights, knuckles, drivetrain components like shafts, gearbox components to the motorsport industry. Some people might say we lose every race. Yes, they are right. But you also win every race, no matter what happens. Pankl is in every professional motorsport car on the world. There is at least a bolt from us, sometimes a bit more, sometimes a bit less. But yes, we've been quite successful in that market. And so we decided to diversify a little bit and to expand this knowledge from track to road and to industrialize the components. So we are delivering parts to the Bugattis, the Paganis, the Rimacs of this world, toys and for the girls and boys of this world, and also the aerospace industry. And we, since 2018, we have a sister company, SHW, being part of the group. They deliver pumps to the higher volume automotive segment. And in all these areas, we are not just a supplier, we are a system partner, because we can deliver complete sub-assemblies, and we can also support our customers as a partner on the engineering side. We are part of the Pierer Industrie AG. This is privately owned by Stefan Pierer, and there are several branches there. One is the Pierer Bajaj, majority shareholder of the Pierer Mobility with the 4 motorcycle brands, KTM, Husqvarna, GasGas, and also recently MV Agusta. Then there is a bike branch under the new mobility area, design, digital transformation, and also the motorsport division. Last year, the Pierer Mobility had a turnover of 2.6 billion and roughly 6,000 people worldwide. Then we have the Pankl AG, which last year had 930 million turnover, 4,600 people. The majority of the people being at the Pankl Racing Systems, and then also SHW, which is the higher turnover share. Digitization is a key tool for us, and the ones of you that are a bit familiar with racing might know what DRS means, drag reduction system, a switch that you can flick in order to optimize the boost, the performance of the car. And we consider digitization as our DRS in our engineering and production. And that's what I would like to show you on the next couple of slides. Starting with the engineering, when we talk about engineering at Pankl, we have 4 disciplines that are key to us. The one is the material science, where we talk about developing new materials, optimizing existing materials in terms of alloying elements, coatings, heat treatments, anything which is related to material science. Then obviously there's the design, the concepting area, where we want to use the data from these materials to optimize our components. The simulation, generating colorful images via ANSYS products here, giving us a feedback on the probability and of success of the probability of performance benefits here. But very importantly also our test benches. We have numerous test benches. We have a suspension corner dyno. We have 2 engine hot stands. We have 2 engine test beds. We have numerous coupon testing. We have torsional rigs. We have drive shaft dynos, gearbox dynos. They all help us to validate the data that we generate via our simulation and help us to refine the boundary conditions. And last but not least, an electronic department where we have component integral measurement devices. We want to record the load data that our customs are seeing on the track, because we need to see what is the next input data, because we all know crap in, crap out. And obviously we want to avoid things like this. This was not the Pankl product here. We make this product, but we know what the failure was here. First of all, it was input data. As you might see, it's maybe not the best to be seen here. This is Shanghai circuit, actually, where there is the race on this weekend. And there's a very, very long straight, so very high downforce, very high speeds. And I don't know for what reasons, but they have built in, I don't think it's purposely, but there is a bump right in the braking zone. So there's a very sharp corner where the cars are braking, so there's a lot of force on the front wheels, and exactly there, you have all the load of the car on the front wheel, there's a bump. It happened to be there. And additionally, at that time, the team was using a very new aluminum alloy, an alloy with unbelievable strength and unbelievable properties, besides elongation to failure. And this was the reason. This was not properly tested, and this is also one reason, because very good properties in L direction, in LT direction, but always if you know a little bit about forging, the short transverse direction, the ST, is the critical one. You always have to look at the worst case properties, and they were horrible in this case, which then led to a driver losing both front wheels. Luckily, nothing happened to the driver here, but this is a very good example how important reliable data is. And this is really the basis for our engineering. We have scanning electron microscope in-house where we can do the complete analysis of failures, where we want to test the components. We never trust our material suppliers, but that's not only due to them not performing. This is really, we have dedicated heat treatments. We have dedicated surface finishes here. So we need to collect all our data that we use in our design, in our simulation ourselves. Therefore, we have various rigs, and therefore we can generate these material charts, these load charts, and match them with each other. And the first step is to have the data, to test it, coupon testing, static testing, fatigue testing, but the next step is to optimize it. That's why we also decided to invest heavily into heat treatment facilities. We have aluminum heat treatment in-house, titanium, steel, vacuum heat treatment. We have plasma nitriding in-house. We also have our own HIP for hot isostatic pressing in-house, which enables us to tune the processes. Because everybody can invest in these machines, but first of all, yes, you need to have the money for that. You need to have the right people to operate it. And then you need to have the skill set to turn the right knobs in order to make dedicated heat treatments. Whenever you go to supplier, they have normally dedicated processes where you can get a very good cost-performance ratio. Whenever you want something exotic, normally the cost is exponential higher here. And that's why we said we want to have our own handle on it, have the handle on the quality, have the handle on the lead time, and have the handle especially on the engineering side. And then, once we've done all of that, we validate it on our rigs and feed back this loop into the optimization cycle. Now, where does the digital transformation come into place here? Obviously, we started, like I guess most of you here, quite early enough with CAD systems and with simulation tools, which I think we are definitely quite far ahead in our digitalization roadmap, introducing topology optimization now for the new potential production methods and the production techniques that you have. A very important step which you're currently taking together with ANSYS and CADFEM is the introduction of ANSYS Granta here, because I mentioned about all the material data that we have, and like in a lot of areas, there is a lot of data, but there's not a lot of information and knowledge coming from it. And that's exactly what we want to do. We want to combine all the information, all the results we get from our tensile testing, from our pulsing, all the samples we send to our customers, everything we collect from a test rig and feed it into our database, generating a more accurate knowledge on the materials, as I explained before, which is then the basis to really optimize the lightweighting of the components. And last, we take this data, this engineering, and also optimize our manufacturing methods and digitize the manufacturing using new tools like additive manufacturing, which I will come to in a minute. We talked about the engineering, being an engineering partner to our customers, but we are also a system supplier, as I mentioned before. We have numerous production technologies in-house. We have steel and aluminum forging, 9 steel forging presses, 3 aluminum forging presses dedicated to high volume production for automotive. Steel and aluminum casting, but only for our brake discs, high performance, lightweight brake discs, which are manufactured in-house. Steel and aluminum press sintering, especially as the subcomponents for the pumps. Additive manufacturing, 8 additive manufacturing machines, all kinds of CNC machines from gear manufacturing, gun drilling, honing, 5X machining, mill turns, you name it, and the heat treatment that I just mentioned. All that combined with the engineering, with the testing, the assembly, and a lot of services afterwards. I mentioned the scaling electron microscope for failure analysis. of the parts of our competitors. Ours don't fail. And obviously the digitization part with the electronics in here. Why do we believe in additive manufacturing? We generated an additive manufacturing competence center, which is amongst the leading ones in Europe, and I think amongst the biggest ones globally as well. We have a cooperation with Böhler here on the powder side. Böhler Special Steels is manufacturing dedicated powders for us. We can use also all their laboratories for the powder investigation, the rheology, the sphericity, the gas content of the powder, which is a key, again, here for the performance of the components. We have a partnership with EOS, the Munich-based company on the machines. We are a technical partner there, involved in their pre-development, testing, beta testing new machines, being involved in the software development that they are doing in the industrialization. Obviously, the final machining, as I mentioned before, is in our standard Pankl divisions. The heat treatment, post-treatment, the heat treatment I already mentioned. The post-treatment also is in regards to surface finish, surface optimization, here the material investigation and the testing. All of that under one roof, and you can see again here a holistic approach because we want to have a handle on the complete process, optimizing the additive manufacturing. Why do we believe in additive manufacturing? Because we think there are several benefits here. And I like to quote Albert Einstein on that. You might know this quote. The world as we have created it is a process of our thinking. It can only be changed by changing the way we think, changing the way we act. Yeah? And this is very important because if we tackle additive manufacturing, if we want to tackle products and engineer products with additive manufacturing the way we've done it before, we will not explore the total benefits that can be done. There's more freedom to design and innovation, lightweight construction, but in a lot of areas we have to stop thinking in materials. We have to think in functions. What are the functions that we need? Because it could be that in additive, something in titanium makes more sense than in aluminum. We have to think, what is the final requirement here and how can we do it? Lattice structures, for instance, is something where we do a lot of engineering on, because if you go some of the additive trade shows, you will see a lot of components that are done with lattice structures, but with a basic engineering and mechanical structural understanding, you will understand a lot of them will not work. So there's a lot of design that has to be done, and also for our simulation, we are generating at the moment replacement models, because obviously having all these fine lattice structures in your structural model will increase your computing time significantly. So we are generating replacement material properties which will enable us to use the lattice then in our simulation. It can simplify your life because obviously we have shorter lead times, less storage cost, elimination of tools, and it's sustainable. However, we all know the future is not a one-way track. And I like to compare additive manufacturing, and we talked about that yesterday, with electric mobility. Mr. Bauer just mentioned that in 2035, supposedly there is the end of the internal combustion engine. If you look at the current sales rates that we see in Germany and Europe, this will be a tough sell, I guess, like selling electric vehicles is at the moment. I'm not against electric vehicles, but I think what we all have to realize, we have to use the right technologies for the right applications. There is no point in using an electric vehicle when you power it with coal energy that is coming from coal production. We are looking, and this has to be our goal globally, at the sustainable mobility, and therefore we have to find the right solutions for the right applications. And it's the same with additive manufacturing. Additive manufacturing had a big hype, and there were a lot of discussion if it will replace the complete production industry. No, it will never. It has its place there. It is one interesting technology enabling us engineers doing freaky designs, doing interesting developments, optimizing the lightweighting. But it will not replace forging. It will not replace casting. It is one addition. For us, it is very important because for us, in our niche markets, high-performance vehicles, hypercars, race cars, aerospace, there is only a finite number of parts that they need per year. Hypercars are produced in 50 cars per year. Race cars is 10 to 20 of a year. In these areas, it makes perfect sense. And it helped us to rise to new heights. In motorsport, obviously, already in the past, we conquered pedestals. But using additive manufacturing will be our key to secure that in the future. For instance, 2026 engine regulations, you mentioned that before. There is a big focus on introducing this hybrid technology, which they have now already, by the way, as well. But they're going to increase significantly from approximately 20% to 50% the hybrid content. Still, there is a massive development on the internal combustion engine, which has to be done because the efficiency on the combustion engine will still bring 50% of the remaining power. And, by the way, as Formula One opted against drive shafts in the front, which is a pity for us because we deliver drive shafts there. We would have had 4 on the car, but now it's only 2. There is not so much recuperation potential because on the front you could recuperate a lot of energy. Now they are only recuperating on the back, which means in order to get all this energy, they might be forced to power the battery or to charge the battery with the internal combustion engine. Which means we need to be very efficient with our internal combustion engine in order to get all the battery charged up and ready to race on the long straights. So some of the developments we are doing in printing, like the turbine housing here, they will be key for 2026. We save lives. Obviously, I think none of us want to be sitting in that car. But you might have heard the top frame. It looks very similar to the halo in F1. But the top frame has a shield. You can slightly see that here. There's also a shield around there. We are the one-make supplier to the Indy Racing League. This component is printed on an EOS M400-4, 4 lasers working simultaneously on this machine, printed in titanium, 5 components welded together. And almost every second week we get an email thanking us that we saved the lives of those drivers. And this is done with additive manufacturing, understanding the structure, understanding the behavior, and using this new methodology. Why is additive so important here? Because obviously it is a structure which has to be very rigid. It has to sustain the crash load here. But on the other hand, it is so high up in the car that it needs to be as light as possible for the center of gravity. We conquer space. Obviously a bit tricky in terms of confidentiality. That's why I was told not to show too much of the components here. But space industry is very key for additive manufacturing. Low volumes, weight, very essential. Most of the parts done in the 316L. Here, this is a big potential for additive manufacturing. And last but not least, we use our group synergies and we can unfold the magic of additive manufacturing. Our cooperation with KTM, obviously there is a lot of potential for additive manufacturing. We looked at the footrest already. You've shown that in your simulation. A very good tool, a very good part printed in additive manufacturing. But there are a lot of other parts where we help our sister company KTM in improving their performance on the racetrack. But not all that glitters is gold. Especially before COVID, there was a massive hype around additive manufacturing. Almost every company said, we need to have additive manufacturing, it needs to be there, it will revolutionize the world. And then it all ebbed up because we all kind of found out, well, there's a price tag to it. There are technical challenges, repeatability, there are engineering challenges. And so we really came out of the throes of disillusionment, and we are seeing an increase now in a lot of areas. But as I said before, focusing on the right application is the key. And there are three main areas that we have to address here. This is productivity, and you see here these are the footrests. We have a very special program with US here called Smart Fusion and stacking, where all of a sudden we can increase the part count per print job from initially 36 pieces to now more than 120 pieces. And this is then almost reducing the cost by at least 50 to 60%. And this is obviously a massive game changer. Will this be mass production? No, it will not be mass production, but it will open different doors and it will be key to move forward. Post-processing, a very painful thing here, all the deburring that you need to do, all the manual rework. This is all cost, labor cost here that we need to reduce, that we need to optimize. But finally, it's the quality. The quality is key, and that's also something where we want to work together with ANSYS and CADFEM here to work on solutions that can really in situ measure the quality, the performance, and if we have to reject a component or not. There are tools here that monitor the melt process, and now we have to correlate these tools using simulation, using machine learning, using feature recognition to really direct these properties to the component and have a decisive tool for us if we can use the parts or not. Because the more we can improve the quality, the less we have to use CT scanning and extra cost here. Again, the more it will enable us to use additive manufacturing for also lower cost applications. We've seen that digitalization is a key for us. It helps us in engineering, it helps us in production. And we started off the presentation with digital engineering is our DRS and helps us to claim pole position. Obviously, claiming pole position is the first step towards victory. And we think this is key for us to be on the forefront also in the future. Thank you very much for your attention.